Problem statement is given to draw the projections as usual, draw the xy line and the position of point P, which is one end of the line PQ, is not given, but the position of point Q with respect to horizontal plane and vertical plane is given. Therefore, we can mark Q dash, the front view, at a distance of 15 millimeters above xy line, and through that point draw a horizontal, and that gives the locus of Q2 dash. And its corresponding top view, that is top view of point Q, lies below Q dash, and on the perpendicular projector from Q dash mark point Q at a distance 25 mm below xy line, and through this point draw a horizontal, that is the locus of Q1. The distance between the end projectors is given as 50 millimeters in the problem statement. Note Q dash Q line is one end projector. Similarly, the line connecting the front and top view of the point P is another end projector. The distance between the two end projectors is 50 millimeters, and that 50 millimeters distance is parallel to the line of intersection of HP and VP. So line of intersection of HP and VP is nothing but XY. So mark a distance 50 parallel to XY, and through that draw a perpendicular. So this is the perpendicular. So this line is one of the end projectors. The other end projector is Q dash Q. On this end projector line, point P dash and P will lie. Where P dash and P can be located, make use of the data. Elevation is 60 mm long. And plan of line PQ is 70 mm long. Elevation is nothing but the front view. Plan is nothing but the top view. Therefore, mark point P dash at a distance of 60 mm from Q dash and join Q dash and P dash. So that is our front view. And measure that, or not measure, it is already given. The dimension is 60 millimeters. Similarly, we can mark point P and join QP, that is the required top view, and the distance is 70 millimeters, that is plan. So the projections are complete. Our aim is to determine the true length PQ, traces of PQ, and the inclinations. For determining the true length, draw a horizontal through P dash and P, because we know P dash Q dash is equal to P dash Q1 dash. So P dash Q dash is the front view whose length is equal to 60. And where is this Q1 dash? So P dash Q1 dash length is equal to P dash Q dash, which is equal to 60. So to mark the position of Q1 dash, take P dash Q dash as radius and fix P dash as radius, draw an arc until it cuts the horizontal through P dash, and that point is Q1 dash. Draw a perpendicular from Q1 dash and obtain point Q1 on the locus of Q1 line. Similarly, draw an arc with the PQ as radius, P as center, and obtain point Q2. From Q2, draw a perpendicular and obtain Q2 dash on the locus of Q2 dash line. And we know true length is equal to P dash Q2 dash and PQ1. Therefore, join P dash Q2 dash in the front view and PQ in the top view. On measurement, the true length is obtained as 77 millimeters. So the true length is determined. We need to find the inclinations theta. On measurement, it gives the value of 25, and the apparent angle of inclination of the front view is alpha. On measurement, it gives 33. Angle of inclination with VP phi on measurement is 39. The apparent angle of inclination of the top view is beta. On measurement, it is 44. The projections are drawn. True length is identified. Angles of inclinations are found. We need to locate the traces in order to complete the problem. To locate the vertical trace, extend the top view PQ and it meets the XY line at point V. From V, draw a perpendicular. Extend front view and the intersection of that extension with vertical from V is VT. To obtain the front view, extend the front view. Already it is extended and the intersection of that one with XY is H dash. From H dash, draw a perpendicular. That perpendicular intersects the extension of the top view PQ at the horizontal plane. So the traces are located, which completes the problem. Thank you.